In this next segment on fire, smoke, and overheat protection, I'm going to look at installed. We're going to move into installed extinguishing systems. So, on aircraft, we'll have various areas where we have permanently installed extinguishing systems. This is in addition to the portable extinguishing systems we discussed earlier. Extinguishing systems are going to be locations, specific locations that need to be protected because the risk of a fire there is higher than others, and that's because things are, the main thing is that there are fuel sources available. So areas where this is the case is we're going to have turbine engine compartments, so the what's called the fire zone of the turbine engine, as well as the APU compartment, the APU being a small turbine engine. It is in a fire zone as well. And a fire zone essentially is an enclosed space where there are flammable materials, fuels, hydraulic fluids that come together with a heat source. And so the idea there is that the fire zone is a sealable compartment. So anywhere you have even like an APU, if you have a tail-mounted APU at the back of an aircraft, the APU is going to have a firewall between at the front side, basically a solid piece of sheet metal between where the APU is and then the rest of the aircraft. Or on engines, they're a fire zone that's contained inside the engine cowling and is sealed from the aircraft by a firewall that's usually within the pylon area, where it connects to the wing, or a pylon if it connects to the side of the fuselage back on the tail. And so those fire zones are going to be protected, and they are a sealed space. When I was talking about extinguishing agents earlier, I mentioned that things like halon has to be, or CO2 have to be put into a confined space in order to flush out or push out any oxygen. And so those fire zone compartments are what we flood with that inert gas in order to displace oxygen to help put out a fire. Another area like that are cargo and baggage compartments, and we'll look at in detail. There's different types of cargo and baggage compartments, but again, those are sealed. When we did maintenance on, say, a cargo compartment, there are panels that go in to make up all the walls, and then once they were in, depending on the aircraft, on some we would have to put sealant. It's a bright orange red fire resistant sealant that you put between gaps in panels and over screws and that kind of thing. That's one way of sealing them. Another common way of sealing them is there are special tapes that almost are like a duct tape. They're white, and they've got the FAR specs that they meet printed on them. And you would go around and tape over all the seams between panels, tape over all the screw heads holding those panels in place, and they would essentially create a sealed box or a sealed container in the cargo or baggage compartment that could then be filled with inert gas, halon, CO2, nitrogen, whatever it might be, typically halon on modern aircraft, to prevent those, or to be able to flood that with an inert gas if a fire were to break out. The last area is lavatories, and the reason for lavatories is they're the one area on a passenger aircraft, they're the one area that the crew cannot actively monitor. And specifically in the lavatories is the installed extinguishing system would discharge into the lavatory wastebasket. And again, it's because of that risk of somebody throwing something like a cigarette butt in there, or even like a vape that could be hot, have a hot element in it that could ignite paper towel on fire, because there's paper towels in there for people washing their hands. So the containers that hold these are either stainless steel or titanium. There's a pair of them shown here. These are spherical. Some are spherical. Some are more oblong or kind of pill shaped. I'd say like a capsule shaped. But they usually have rounded ends for strength. And they hold the agent, which is when we deploy the agent, it comes out as a gas, but they're held under high enough pressure that the agent, the halon or whatever it might be, is typically in liquid form when inside the container. And so the idea there is they're fairly compact. The two shown here are probably about the size of a basketball, maybe a little bit larger than a basketball. But then when that gas comes out, when that what's liquid in there, when it's allowed to escape and the pressure drops, it instantly turns into a gas, and it can fill a fairly large volume space. It's going to expand many times over its initial volume. In addition, if additional pressure is needed, if the agent is pumped in, but then they want to add additional pressure to head pressure, there may be also, if there's halon in there in liquid form, there may be some additional inert gas in the form of nitrogen put in, or same thing with CO2 systems. And so these are installed, and there's a few elements. So you'll see here there is a pressure gauge on each of these. And that pressure gauge allows us to verify the pressure. And so pressure is temperature dependent. So when we're inspecting these, we have to make sure there's a pressure temperature chart that'll typically have pressure along the y-axis, temperature, which is what temperature is the exterior of the bottle. And you get a relationship kind of like that where, as it gets warmer, the pressure increases. And so you look at what temperature is it, go up, and then come across to figure out what the pressure should read on that gauge. These also often have the gauges. A lot of times if you look carefully at these bottles, I'll go ahead and delete some of my drawings here. If you look carefully at the bottles, there's actually two wires going to them. There's one right here going up to the pressure gauge. That has, on these pressure gauges on this left side, they each have a pressure transducer. And so that actually sends a pressure up to, say, like an ICAS system or some kind of indication system up on the flight deck. So in addition to being able to check them manually for maintenance, they're the ability for the crew to know if they've been discharged. In addition to that, we have a second wire going to them. For this one, it's coming in right here. For the other one, it's coming in from this side, and you can see that connects to this tube coming off the bottom. This is the discharge tube, so this goes out, say, to an engine or to a cargo hold, and depending on which bottle it is. And so this discharge, the little discharge wiring there, is connected to something called a squib, which is used to activate and discharge the bottle, and it's an explosive device. We'll look at how that works here in a couple slides. And so you've got those various items connected to them that are used to monitor as well as to activate the bottles when needed. So looking at it more closely, here's kind of a diagram of the bottle and looking at the discharge portion of it. Here's that squib that I showed the wires running to in the last slide. The cannon plug would be connected, the wiring would be connected to the left side of this here, this threaded end. And then this piece right here on the right is actually a small projectile. And so when an electric charge is put across here, it ignites a powder charge in here. There's basically a little bit of essentially gunpowder inside of there. And that shoots or causes the projectile end here to discharge off the cartridge. And it hits what's called a frangible disc. And so on the bottle, what's holding we have this disc right here, and you can see it's scored in the middle. You got these score lines. And so this projectile hits this disc and causes it to burst because of all the pressure in the bottle. And that's what allows the gas to escape from the bottle when that occurs. And inside of this fitting right here that it goes into, there's a strainer. So all those little metal bits get stopped by the strainer. And then the gas continues on its way and comes out the discharge head. And from there, it's going to go to either the engine or the cargo compartment or the APU or whatever it might be that bottle is connecting to. And so These are explosive to discharge. It means once they discharge, you have to take them out. The bottles have to have a new frangible disc put in. They have to be recharged with whatever extinguishing agent they contain, likely halon. And so if we had one discharge at an airline, we usually had spares sitting on the shelf, and we would swap it out. But it's not something you want to discharge all the time. I know some of our bottles, if a discharge occurred, you were talking about roughly a $20,000 to $50,000 replacement, because halon is quite expensive. Just if you're not really familiar with halogenated hydrocarbons, they are greenhouse gases. And so when this does release, yes, it does put the fire out. But then as that gas eventually escapes into the atmosphere, it goes up and it damages the ozone layer. And so they actually don't make a lot of halons anymore. They try to recycle the ones that are there. So when we take these bottles out, if they're at the end of their service life, or if you need to replace them because of overtime fatigue, then the halon needs to be recovered, and it'll be put into another bottle. It'll be moved, used again. But that squib, again, is explosive, so there are safety concerns whenever we're working with these. Typically, when you remove the wires going to it, there's a couple pins inside of here, and you always want to, you have special caps or even just sometimes a piece of safety wire, you short those pins together, because what it is a voltage difference across them that can activate the charge. And so if they're shorted together, that can prevent them from being able to fire. And we just want to be careful of them because they are explosive and they do send a projectile. If you do have these out, just make sure you're treating them with caution. Avoid static. Static electricity can actually set them off, so just be careful. One thing here with the bottles I kind of glossed over, there is a temperature pressure sensitive safety relief on them. So if the temperature gets too high, causes the pressure in the bottles to get too high for some reason, we don't want the bottle itself becoming an explosive. We don't want it bursting, potentially damaging things, and so there's a safety relief valve. And that ties in further down here to these discharge indicators. This is on the outside of the airplane. You can see there are two here. The red one here is in place. The yellow one has been partially discharged. It's rare, sometimes you see them like that, sometimes it's missing altogether. We would always check these on walk-arounds. The flight crews had to check these on their walk-around before every flight to make sure that both discs were present and installed on the outside. And there is one of these, there is one red and one yellow essentially for each fire bottle on the aircraft. And so they cover the port where if the discharge, the red one on the right here, this covers the port where if that discharge valve that I talked about right here, if that pressure safety relief valve releases, this is where it vents the halon or the CO2 into a tube that's on the inside of this. And when it vents, it pushes that red disc out, causes it to pop out. And so you no longer have a disc there. It pops out kind of like the yellow one's partially installed. And so when it happens, that tells you that you had an overpressurization, and you should go check your fire bottle to make sure that it didn't depressurize. Now, most of the time, almost every time I found one of these missing, it wasn't because it got activated. It just simply fell out. They're just kind of friction. They're literally a little plastic disc you shove into that hole. They're slightly bigger than the hole, so they're a friction fit. And if it falls out and you can verify that the bottle still has pressure and there wasn't a reason that it discharged, then often we would be able to just get a new disc, pop it in there, and call it a day. The yellow one is an activation discharge. So in addition to, here where if this squib activates, in addition to most of the halon going to the engine or whatever, a little amount goes here and goes to the little yellow disc and pops the little yellow disc out. And so that yellow activation one there is if the fire bottle's been activated. So same thing, if that's popped, you need to verify that the bottle hasn't been activated, that it was just, it popped out or fell out because of, say, a hard landing or something. And again, most of the time when one of these discs were missing, it wasn't because of any kind of an activation or discharge. They just happened to fall out. But you always got to make sure that there wasn't an activation or a reason they're popped out. In order to activate these fire bottles or cause a discharge, we've got different mechanisms. Some are shown here. So some aircraft use fire push switches. That's shown in these top pictures here, outlined in red. So these are an arm switch, and these are also the switches that when these are like here, the one on the left, one on the right are showing the left engine switch and the right engine switch. If the left engine is the one on fire, the left one here would be the one that would light up red and draw your attention to it. So you would push this switch right here to arm the fire bottle. Now that does not discharge the fire bottle. Okay, when you arm it, it arms the system. It closes various valves that go into that fire zone. Remember, the fire zone is like the cowling area. And so it hopefully removes any fuel from being able to get in there. And it's not just fuel in the sense of jet fuel, but it closes the valves for the fuel. It closes the valves for the hydraulic fluid. So they can't go to the engine because your engine almost always has an engine-driven hydraulic pump. In addition, it also closes the valves that are associated with the pneumatic system or the engine bleed air. And that's so if we have a fire, we don't want that engine bleed air system pumping smoky air up into the cabin. And so by closing that, it seals that fire zone off from the rest of the aircraft. And the other style is shown at the bottom. This is more common in Boeing aircraft, are pull handles. These are the T handles. And so I've got the arrow kind of pointing up, showing up. You loop your fingers under the T handle, you pull up on it in order to do the arm action. And so again, that'll close fuel valves, hydraulic valves, air valves. And in addition to closing off and kind of sealing that fire zone, it determines the discharge point. So again, these don't actually cause discharge of the extinguisher yet. But if you do discharge an extinguisher, they will send it where it's going to go, because we don't have necessarily for like engines, we don't have we don't have fire bottles just for the left or just for the right. The most common configuration is we have two fire bottles. We have two bottles that can be discharged into either engine. And so if I pull this number one handle, that tells the airplane that when I start discharging bottles, I want them to go to the left engine. And it can do that by either activating multiple squibs or multiple valves. I've got some schematics that show that here in a minute. Okay. The second step, though, in order to actually discharge the extinguishing agent, is there's a second step we have to do. And so shown here on the top are a pair of discharge buttons. So if we're dealing with a left engine fire, after we've pushed this top arm button, then these two discharge buttons will light up that are circled in yellow. And those are the two bottles that are available. And so right now, if I push the left one, or if I push the right one, they're both going to go into the left engine if I've armed the left fire system. And so these, essentially what happens is after you have selected the engine you're going to discharge into, then both of these buttons light up that are in yellow, and you can use one or both to put out a fire. With the T handles, remember we pulled the T handle in order to select which engine we want to fight a fire in. Then the T handle can be turned left or right. It can be rotated clockwise or counterclockwise. And so rotating it one direction discharges one of the two engine fire bottles into that engine. Discharging it or rotating it the second direction discharges the second fire bottle into that same engine. If both fire bottles are used on engine one, there are no more fire bottles for engine two. The APU typically has just a single bottle, and you can see that on the button style. This is the APU arm button right here, and then the APU just has a single discharge button below it. On the Boeing style, we have an APU T handle here, and the subtle difference you'll see is the APU discharge right here. It just shows a left and a right arrow, but it's lacking the L and the R that are present on the pull handles for the engines. And so the APU one, once you pull it, it doesn't matter which way you turn it, one way or the other, it's going to blow the single APU bottle. And so this will send that charge to the squib. The squib bursts that frangible disc. This allows the agent to flow from the bottles into the fire. But we typically have two engine bottles, can be discharged into either one. We have a single APU bottle that can be discharged into the APU, and those two engine bottles are independently discharged. The schematic for how that operates in the background, there's two ways it can be accomplished. So the first is shown here. So in this case, we've got two fire bottles that are, they call them the number one engine container, the number two engine container, but really they can be used for either engine. And what you have are two outlets with squibs, with explosive squib cartridges on each one. And so on the number one engine, or the bottles here, if I select the number one engine, you can see the number one engine, this path right here goes to the number one engine, or on the right-hand bottle, this path also goes to the number one engine. So if I turn my T handle, or if I pull the T handle for the number one engine, or if I push the arm switch for the number one engine, that is going to arm both these squibs. Now, it won't initially deploy them. It will arm it. And then the actual discharge button is what's going to send a voltage to the squib in order to cause it to discharge. Okay. And so when that happens, you can see the gas is able to escape here and can come out this way. And if I discharge the second bottle, the gas can come out this way, and both of them go to the number one engine. Okay. Likewise, if I select the right-hand engine, I can select that I want to use the right-hand engine. It's going to arm these two squib sets of wires. And if I push the actual discharge button for the right bottle, that'll cause gas to flow here to the right engine. If I press the discharge button for the left bottle, that'll cause gas to flow here to the number two engine. So either way I can send it. And these T's also have a check valve in it. We don't want the gas going this way. So there's a check valve that causes it, depending on which way it comes from, it's a double check valve. So that's kind of a simple system. And the reason for this, the reason we don't contain a bottle for every engine is the likelihood of multiple engine fires is extremely low. And so it doesn't, the kind of the standard practice is you have two bottles, they can both be used on the left, or they can both be used on the right. Or I guess in theory, you could use one on the left, one on the right. The other way to accomplish this, and now this is shown here. So here's that image a little bigger. I guess I could have blown it up. But the other way to accomplish that, and this is a 3-engine variant, but it doesn't necessarily have to be. It could just be 2 engines, is that we have our handles for our various engines. So in this case, 3 engines. And when those handles are pulled, if you pull the number 1 handle, that's going to open this valve right here. If I pull the number 2 handle, let me switch colors. If I pull the number 2 handle, that's going to open this valve here. Or if I pull the number 3 handle, that's going to open this valve here. And so the number 1 handle will route there. Again, if we just have a twin engine aircraft, you can essentially disregard everything 3, 3, 3. But we'll still have 2 bottles. Now, if I take the handle and if I rotate this number 1 handle to the left, that is going to activate the squib for this right here. And so now that will route extinguishing agent into the number 1 engine. If I turn it to the right, that will cause the number 2 bottle to extinguish. And if that valve is open, it will also go to the number 1 engine. And so this was another way of doing the same thing, but it does involve the fact that you have valves you do have an extra kind of failure point, and the fact that those valves have to open. And so it's not as common. This is kind of an older design, but it is still out there in some aircraft. In any case, if you are operating an aircraft and you have an engine fire, which has happened during taxi before, the typical procedure is not to use all your resources at once. So if I have an engine fire, the first thing I'm going to do is pull the fire handle, or I'm going to push the arm switch, and I'm actually going to wait, because that right there, by pulling that T handle, pushing the arm switch, remember it shuts the fuel sources off, so it closes the fuel valve, it closes the valve going to the hydraulic system, and hopefully that alone is enough to put the fire out. It'll just burn out because of lack of fuel. And if that takes place and all your lights go away, your continued warnings, then you know the fire has gone out. But after about 30 seconds to a minute, if it hasn't gone out, then I'm going to activate my first fire bottle. And that will then release that extinguishing agent in, hopefully snuff out the fire, get rid of any oxygen that's in there. And again, if I can fight the fire and put it out effectively just using that single bottle, I'm not going to discharge the second bottle. I'm going to save it. One reason to save it is so I have it available in case the fire reignites for some reason. The other reason is if I don't need to discharge it, there's no point in discharging it because it is expensive and more stuff that has to be fixed, repaired, or replaced in order to get the airplane flying again. So I'm going to go ahead and stop this video here, and then I will create one more where we'll look at the cargo fire extinguishing.